Okay, so for the last week, we're going to be looking at probability, and today we're going to be looking at probability scale and calculating probabilities. So what is the probability scale? It tells us how likely something is to happen, and we can represent it on this line here. So let's have a look at a few examples. We're very unlikely to win the lottery. It's probably likely that it will rain tomorrow, and we can be certain that Christmas Day will be on the 25th of December. So instead of just using words though, we like in maths to give probability a numerical or number value. So we can have the same sort of number line, but notice that impossible has a probability of 0 and certain goes all the way up to 1. So for something certain going to happen, it's going to have a probability of 1 whole. Notice even chance is half. So you may have heard of 50-50 before. So half and half chances. So the probability you will roll a 7 on a standard dice will be 0. It's impossible because you've only got numbers 1 to 6. The probability you flip a head on a coin has an even chance. As long as that coin is fair, you've got half a chance to flip a head and half a chance to flip a tails. So from the probability scale, the main points we need to see are that the sum of the probabilities must equal 1. So we saw that if something is certain, it has a probability of 1, and if something is impossible, it has a probability of 0. The most important one here is the sum of all probabilities must equal 1. So try and remember that one. The first thing you're going to do today is follow this website, which will be on the attached link on Show My Homework, and have a go at this game here. So you'll be given 4 drinks in the vending machine, and you've got to look at this question here and say how likely it is that you're going to get the one they want. So is it impossible, unlikely, equal, likely, or there'll be an extra option for certain. In maths, we want to be able to give a probability as a number rather than just saying it's likely to happen or unlikely. We want to have a numerical value. So we know that the total probability of all outcomes must add up to 1. However, probabilities can be shown in 3 different ways. They can be decimals. So for example, you could have a probability of 0.5. It could be in fractions. So the same as a probability of 0.5 would be a half. And it can also be shown in percentages. So remember, 50-50 was equal chance, so 50%. So even though we say must add up to 1, so in decimals, the certain probability will be 1 because it's got to add up to 1. In fractions as well, it's going to be 1. But just make sure that for percentages, remember the whole percent will be 100%. So just be careful with that. So we've got 3 different ways we can show probabilities, and you'll have to answer differently depending on the question. If the question gives it in decimals, then give your answer in decimals. If it gives it in fractions, give your answer in fractions, and so on. So let's have a look at an example. Here my probability is given in decimals, so for all my answers I'm going to give them into decimals. The table below shows the probability of picking different coloured counters from a bag. So we can see red has 0.23 and so on. Fill in the missing probability here. Well, let's look back up to here. All outcomes must add up to 1. So I know that the probability of red plus the probability of blue plus the probability of purple plus the probability of green plus the probability of yellow must add up to 1. So I can find that missing value. Well, let's see what I've got so far. I'm going to do 0.23 plus 0.25 plus 0.27 plus 0.1. Just going to put a 0 there, remember, for adding decimals. So let's add them up. 3 plus 5 plus 7 is 15. 2 add 2 add 2 add 1 add 1 gives me 8. Don't forget the decimal point. And then 0 is added up. So far, the total probability I've got is 0.85, but I know I need to make them add up to 1. So I need to do 1, take away 0.85, and that's going to give me 0.15. So I know the probability of purple must be whatever's left over to add up to 1, and that's 0.5. So that's my part A. Part B, what's the probability of picking a red or a green? Well, the probability of red is 0.23. That's the probability of red. And the probability of green is 0.27. So the probability of picking one or the other, I've just got to add those two together. 0.23 plus 0.27 gives me 0.5. Okay, so that's my example there. Remember, I was given the probabilities in decimals, so I gave my answers in decimals. Your turn now, very similar. Have a go at these two questions, pause the video, and then we'll go through the answer. So for part A, we've got to find the probability of yellow. So remember, all of the colours added together need to make 1. So let's see what we've got so far. 0.2 plus 0.13 plus 0.08 plus 0.27. That's going to give me 3 plus 8 plus 7 gives me 18. 2 plus 1 plus 2 plus 1 gives me 6. So I've got 0.68 in total, but I need to make it up to 1. So 1 take away 0.68, and that leaves me with 0.32. So that must be that missing value there. Part B, what's the probability of red or green? Probability of red is 0.2. Probability of green is 0.27. So all we need to do is add those together, and I get 0.47. So those are your two answers there. So exactly the same question again. However, we're given our probabilities as fractions this time. So our fractions, we're going to do exactly the same, but it's got to add up to 1. We're just going to be adding up fractions instead. So for part A, I've got to fill in the missing probability. So the first thing I need to do is, I know all of them added together have got to equal 1. So what have I got so far? I've got 1/10 plus 4/10 plus 2/10. This one's quite easy. All the denominators are 10 on the bottom, so I can just add the numerators. 1 plus 4 is 5, plus 2 is 7. So I've got 7/10 so far. I need to make my probabilities add up to 1. Well, how do I get 7/10 to be 1 whole? Well, to be 1 whole, it would be 10 out of 10, wouldn't it? Same on the top as the bottom. So what I've got missing is 3/10. So that must be the probability of green there. So remember, 1 as a fraction is any number where the top is the same as the bottom. So if I have 5 out of 5, that's 1 whole. If I have 200 out of 200, that's 1 whole. Okay, so it's got to be the same as the top as the bottom, and that makes just 1 whole. For part B, I've got to find what is the probability of picking red or green. Well, the probability of red is 1/10, or I can have the probability of green, which is 3/10. So I'm going to add those two up. So remember, adding fractions, the denominators have got to be the same, and then we add the tops, okay? You could simplify if you want and make that 2/5, but with probabilities, normally we keep it in the form that it gives us the answer as. Okay. Your turn now, exactly the same. Pause the video now, have a go, and we'll go through the answers in a second. So for our answers, to find the missing probability, we've got to find the probability of it being purple. So we've got to add up the fractions that we've already got. So the denominators are all the same. That's good. That makes it easy for us. We've got 5/10 so far from red, blue, and green. So what do I need to add to that to make it up to 1 whole, or to make it up to 10 out of 10? We've got to add 5/10. Well done if you notice that's 1/2. You could have put that as well. Part B. What is the probability of picking red or green? Well, the probability of red is 1/10. The probability of green is 2/10. So in total, that should be 2 plus 1 over 10, 3/10. Here are some practice questions. So if you found what we did quite easy, go on to the orange challenge questions straight away. However, if you want a bit of practice, go for the green 3 questions. Pause the video now and give them a go. Here are your answers, so mark them off. Notice the third question was with percentages, so well done if you got those right. Remember, 1 whole in terms of percentages is 100%. So given a scenario, how do we calculate probability? So you need to write this equation down somewhere. We will use this a lot. The probability of an event happening equals whatever event we want, so the wanted outcome, so how many times can that outcome happen, divided by the total number of outcomes. So we will see what each of those parts means with the next 4 examples. Okay, 4 different scenarios. We've got flipping a coin, turning a spinner, rolling a dice, and picking out marbles from a bag. So we're going to show you an example from each. The first example with flipping a coin. So remember with a coin, we either have heads or we have tails. So we've got 2 possible outcomes. We're asked, what's the probability of getting a head? Well, the number of times I can get a head, the possible outcomes for that is just 1. I either have a head or I have a tail. So for the top bit, the wanted outcome, there's only 1 chance of that happening. And what's the total number of outcomes? Well, I can either have heads or tails, so that's 2 different outcomes. So the probability of a head is 1 out of 2, or 1/2. Moving on to the spinner. We've got 4 different outcomes, haven't we? We've got red, we've got getting yellow, we've got getting blue, and we've got getting green. So when we're asked what's the probability of getting a red, well, the wanted outcome, because they're all the same size, they're equally as likely. So the probability of getting red is this 1 section here. 1 section out of how many total sections? Well, there's 4 different colours, so 4 different total sections. So 1 out of 4. We could also write that as 0.25 because that's the same as a quarter, or 25%. Normally we will go for fractions. Probability of red or blue. Well, how many different areas could it hit? Well, it could hit red or blue. So the wanted outcome, there's 2 possible wanted outcomes because it could either go in the red section or now the blue section. So there's 2 of those. The total number of outcomes, though, is 1, 2, 3, 4, the 4 different colours. So 2 quarters. Or you could simplify that as a half because it could land in any of this half, and we can notice that's half of the circle. Okay, what about the dice? Well, remember with this dice here, we've got 6 possible numbers it could be. 1, 2, 3, 4, 5, or 6. So what's the probability of it rolling a 6? Well, how many wanted outcomes are there? Well, just 1 because it could only land on the number 6 once out of any of those numbers there. 6 only appears once. And how many total number of outcomes are there? Well, how many different possibilities of numbers are there? There's 1, 2, 3, 4, 5, 6. Okay, so notice I didn't put 6 out of 6 because there aren't 6 chances of getting 6. There's only 1. There's 6 possible numbers, but only 1 of them is a 6. The second bit says the probability of the number being even. Well, we can see there's 6 numbers. I'm going to highlight which ones are even. So 6, 4, and 2. 2, 4, and 6. So now let's go to the equation. The probability, this P, that's all it means. The probability of it being even. Well, how many wanted outcomes are there? That's going to be all the even numbers underlined. There's 3 of them. So there's 3 possible outcomes there could be for it to be even. And how many total number of outcomes are there? 6. There's 6 numbers. So you could leave it like that, Or you could say, well, that's half, 50-50, whether it hits even or odd. Last example is taking marbles out of a bag. So we've got 2 blue, 2 green and 2 red. What's the probability of picking a blue? So let's go to our equation again. The numerator is going to be the wanted outcome. Well, we want to pick blue, and there's only 2 chances I could do that. There's only 2 marbles that are blue. Divided by the total number of outcomes, there's 1, 2, 3, 4, 5, 6 marbles to choose from. So our probability is 2 out of 6. What about the probability of it being not blue? Well, for the numerator, the wanted outcome, the total number of marbles that are not blue are 1, 2, 3, 4. There's 4 that are not blue. And how many are there in total? Well, there's 6 marbles in total, so we get 4/6 for our answer. I've shown you 4 examples on the last slide, so you're now going to choose how confident you are. There's going to be bronze, silver and gold questions, so choose which questions you'd like to go through. There's an attached file on Show My Homework to choose the selected questions you want, so either pause the video on the question now or just have a look at that worksheet. Here are those answers. So here's your bronze answers, silver answers, and gold answers. A challenge question now. So working on frequency tables that we've seen before, have a go at this question here, pause it, and then we'll go through the answer on the next slide. Well done if you're giving this one a go. So let's just remember the probability equals the wanted outcome, so the number of wanted outcomes, divided by the total number of outcomes. So I'm always going to need that formula when I work out the probability. Part A says work out the probability that the student has a shoe size of 8. So looking at the table, let's see just what it means. Remember, frequency means how many. So 2 people had a shoe size of 5. 11 people had a shoe size of 6, and so on. So how many people had a shoe size of 8? The first bit of my probability is the wanted outcome. So that is how many people have this size 8. So that's going to be the top half. And the bottom half of the equation is the total number of outcomes. So the total number of people asked, or the total of how many there are, or the total frequency. So how many people were size 8? So we've got to look at this row here, look at the frequency, and we can see that is 4. We've got to say out of how many people in total. Well, remember, how many people in total is all of those numbers added up. So 2 plus 11 is 13, plus 5 is 18, plus 4 is 22, plus 1 is 23. So the probability of picking someone with a size 8 is 4. So 4 people had size 8 shoes out of a total of 23. Part B, work out the probability that the student has a shoe size of 7 or smaller. So the probability that the size is 7 or less. So our wanted outcome, this bit on the top of the fraction, is going to be anyone who's a size 7, 6, or 5, because that's 7 or less. Let's get rid of this bit here. And the bottom of the fraction, remember, is going to be the total frequency, which luckily we worked out on the last question, which was 23. So I've got that bottom bit sorted already. I just need to sort the top bit. Well, the number of people who have size 7 is 5. The number of people who have size 6 is 11. And the number of people who have size 5 is 2. So the top part of this fraction is going to be 5 plus 11 plus 2, which gives me 18. And so therefore our probability of being 7 or smaller is 18 out of 23. Finally, to finish off, you're going to play a game of higher or lower. So you'll see, if you follow this link here, which will be attached on Show My Homework or on the worksheet PDF, you are going to get to this screen here. You're going to click on Single Suit. Notice, remember that cards go ace, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you've got Jack, Queen, and King. King is the highest numbers you can get. Ace is the lowest. So you'll start your game. Let's say this one here, you've got a 10 card. So you've got to think, how likely is it that I'm going to get a card higher? How likely is it that I'm going to get a card lower? Well, let's have a look at this number line here. It's more likely that you're going to get a card lower, because look how many cards I could get for that are lower than 10, whereas there's only 3 higher. So I would go for lower here. If you want to work technically, each time you can bet a certain amount. So this is how confident you are. So I'm quite confident that the number will be lower than 10. So I'd probably move the bet up to about here. Once you've completed your sequence of higher or lower and get to this final card, you'll have a total number of points. This is just an example of me playing the game. So I went lower to start off with. I increased my bet a little bit because I thought it would definitely be lower. Notice A is the smallest card. So I bet all my money and gone higher because I know for sure it's going to be higher than an ace. So I keep playing Jack's quite a high card, so I think it's going to be lower. Oh, that was unlucky, so I lost that one. I'm very confident it's going to be higher than 3 because there's only 2 cards lower. So I scored 184 points. So once you've finished that, play one round, so get to the end like I did. Send me a picture of your score, and the top 3 will win lockdown points. You can have as many goes as you want to try and beat your high score.